So it turns out that functions can be added, subtracted, multiplied, or divided just like we can with numbers. So in our first example, we're going to take a look at adding and subtracting two functions. Now notice the notation. We're using this function notation. We can use any letter we want. Typically we use f for function, but we'd say f of x or g of x or any letter we want of x. Remember, that's just a fancy y, really. It's just a special notation. F is not a separate variable. And so what I've gone ahead and done, I've already set up my expression. I'm going to add the two functions together and then we'll subtract them. So I've written them in a vertical format, though you don't have to. All we're going to do is we're going to add up like terms or subtract like terms. Now these problems tend to have lots of fractional exponents just to continue working with what we've been doing in the last couple lessons. But we can add any kinds of functions together, any kinds, whether they're linear or quadratic or these weird ones in this case. So once again, we're looking for like terms. When we add like terms, we have to have the same combination of exponents and variables and everything, and things line up really nice with this. So when I go ahead and I add coefficients together. So 4 plus -9 gets me -5. And then once we're adding, or when we're adding, our exponent does not change, so that stays x to the 1/2 power. The next two terms are also like terms. They have the same exponents right there, so I'll add the coefficients and get 8. And then once again keep that exponent the same when I add like terms. So there is the new expression that represents the sum of those two functions. Our answer is not a nice number, it's a brand new function, a brand new equation or expression in this case. Subtracting is going to work the same way. I've gone ahead and done a vertical format again. If you want to just write it side by side, that's fine. Once again, to subtract, we're looking for like terms. Now if you're like me and hate subtracting, what I would do is I would change that to an addition problem, which we're allowed to do. It just means you have to change the sign of everything after it. So that'll become a positive 9x to the 1/2 and then a negative 5x to the 3/4. So now I'll just add up like terms. This will get me 13, and once again our variable exponent does not change when I'm adding like terms, and then minus 2x to the 3/4. So there's the what represents the difference of those two functions. Now I forgot to mention, notice I wrote each thing down in parentheses in the original setup. That was important, especially when I'm subtracting. I wanted to make sure I subtracted both parts, or in other words, distributed my negative sign. That's a common mistake. People forget to make sure you subtract everything after that. So include parentheses when you set these up. Let's go ahead and take a look at a multiply divide example as well. So we can multiply and divide two functions as well. So I have two new functions this time. Remember, those functions can be anything we want to work with. In this case, once again, we're working with these exponents that have rational, or these problems that have rational exponents, just to continue working with some of our rules with exponents. So when I multiply, coefficients behave like they always behave. So I'm going to multiply my coefficients together and get -50. And then my exponent rule, the base is x. They both have a base of x. Some people try to argue that they don't have the same base because one's a 5x and one's a -10. But remember, 5 and -10 are coefficients. The base is what has the exponent on it, and that's just the x. So these do have the same bases. When bases are being multiplied and are the same, exponents add together. So we'll add up those exponents. If you need to use a calculator at this point to add those two fractions together, go ahead and do that. We'll take a look at adding fractions by hand, or review of that in another video. So for now, I'm just going to get 23/10 using my calculator as the exponent. So once again, we're getting brand new expressions as answers, not just single numbers. Don't forget the x. Some people forget to include that when they write their exponent down. And dividing will work a very similar method. So I'll divide my coefficients once again to get started. 5 divided by -10 is just -1/2 when I simplify that. And the negative sign can be on top or bottom. It doesn't really matter. And then once again, the same base is being divided. That x base is being divided. So I'll do the division by subtracting my exponents. And always do the top exponent minus the bottom exponent, and write your answer in the top of the fraction. Move it if it comes up negative to the bottom. But in this case, it shouldn't. So once again, using a calculator, unless you want to do it by hand, 3/2 minus 4/5 leaves me with 7/10. As my exponent, it comes up positive, so I don't need to move it. So there is my simplified expression once I divide those two functions.